The immense universe that surrounds us is made up of hundreds of billions of giant star formations called galaxies. In one of them there is a pale blue dot that we call home, the planet Earth. This dynamic planet has all the necessary conditions for the development of the extraordinary complexity we call life. One of the many millions of living species that appeared on Earth has evolved so much that it has dominated everything else. It is our species, humans. We managed to develop a very sophisticated technological culture that raised important questions about our very existence and the natural environment we are living in, and eagerly we are seeking for answers. On a small part of land on Earth called Europe, nations cooperate in all areas of human activity, working towards a major economic, cultural, and political integration. Part of this common effort is ESA, the European Space Agency, an intergovernmental organization of 22 member states established in 1975. ESA is Europe's gateway to space. Its mission is to provide and to promote, for exclusively peaceful purposes, cooperation among European states in space research and exploration. By coordinating the financial and intellectual resources of its members, it undertakes programs and activities far beyond the scope of any single European country. In short, ESA's job is to draw up the European space program and carry it through. ESA's programs are designed to discover more about Earth, the space environment, our solar system, and the universe. ESA builds rockets and space carriers that can carry Earth-observing satellites, space probes to other planets, and astronomical observatories in space far from Earth's atmosphere. ESA participates in the most advanced space outpost we have, the International Space Station, or ISS. It is a space station in low Earth orbit. The ISS is a joint project between several space agencies: the US NASA, the Russian Roscosmos, the Japanese JAXA, the European ESA, and the Canadian CSA. The first ISS component was launched in 1998, with the first long-term residents arriving on the 2nd of November 2000. Since then, the station has been continuously occupied and upgrading with new modules and instruments. ISS is one of the most important laboratories for the advancement of our scientific knowledge and especially of our technology. All technology devised for this challenging project, combined with the results of the numerous experiments performed there, soon will become part of our everyday life, changing our civilization and providing solutions to problems we are confronted with today. ISS is one of the most precious investments we have ever made. The universe is enormously vast. The only messenger that can travel such large distances and bring us knowledge about the distant celestial bodies is light reaching Earth. This is the natural planetary show that we can observe with our eyes each clear night on the dome of the night sky. That is what astronomers called visible universe, the universe that we can see. This light, however, is so dim and the signal gets so weak with distance that we need to build huge telescopes to capture it. But would this be enough to see the whole universe? The visible spectrum, that is, light that we can see with our eyes when we look at a rainbow, makes up only a small fraction of the different types of radiation that celestial bodies emit. All this means that there is a lot more going on in the universe that we cannot see. On one side of the visible spectrum, we find the types of light that are lower in frequency than visible light. These types of light include microwaves, infrared rays, and radio waves. On the other side of the visible spectrum is ultraviolet, X-ray, and gamma-ray radiation. These types of radiation are made up of extremely high energies. Gamma rays are the highest in frequency and energy. These invisible types of light can be detected by specific sensors or cameras. Such images of the night sky in all parts of the light spectrum extend tremendously our ability to observe the cosmos. Earth's rich atmosphere acts as a shield and protects life from the hostile environment of space, but prohibits most of the light to pass through. Furthermore, the turbulent atmosphere degrades the images in telescopes on Earth's surface. Thus, the only way to observe the universe comprehensively and with clarity is to employ specially designed telescopes in space. Until now, the biggest space telescope is Hubble, which has a mirror of 2.4 meters. It orbits Earth every 97 minutes at a distance of 569 kilometers. Hubble can point towards an object continuously for 24 hours. Since 1990, it has recorded some of the most detailed visible light images, allowing a deep view into space. Many Hubble observations have led to breakthroughs in astrophysics, such as determining the rate of expansion of the universe. The successor of the Hubble will soon be the James Webb Space Telescope. This telescope has a 6.5 meter mirror and is designed to observe in infrared light. It will be able to observe galaxies at a distance of 13.5 billion light years from Earth, and to see not only far in the universe, but also into its distant past. The Planck Space Observatory was launched in 2009 for cosmological studies and also to map cosmic microwave background radiation, turning the clock back and revealing the infant universe as it was only 380,000 years after the Big Bang. Infrared radiation is primarily heat or thermal radiation. The Infrared Space Observatory, a cooperation between ESA, NASA, and JAXA, and the Herschel Space Observatory, operated in the infrared light spectrum. They could observe astronomical objects that remain hidden for optical telescopes, such as the star hatcheries and nurseries, the coldest and dustiest cocoons where stars are born, as well as dusty galaxies just starting to bulk up with new stars. Active from 2009 to 2013, Herschel was the largest infrared telescope ever launched, carrying a 3.5 meter mirror and instruments sensitive to the far infrared and sub-millimeter wave bands. It sifted through star-forming clouds, slow cookers of star stuff, to trace the path by which potentially life-defining molecules such as water are synthesized. ESA has also aimed to observe the positions of billions of stars in our galaxy with unprecedented accuracy, known as astrometry. Using observations in visible light, the Space Observatory Hipparcos managed to measure and catalog the positions of 118,000 stars. The Gaia satellite, which is designed to measure the brightness, position, and motion of more than 1.3 billion stars, has already produced the most detailed three-dimensional map ever made of the Milky Way. Launched in the late 70s, the International Ultraviolet Explorer astronomical observatory satellite was designed to detect ultraviolet spectra. The ultraviolet light observed by the satellite cannot be detected on Earth due to the Earth's atmosphere and protective ozone layer. Astronomers made observations of objects ranging from solar system bodies to distant quasars. Among the significant scientific results from IUE data was measurements of the way interstellar dust absorbs light. And measurements of the supernova SN 1987A, which showed that it defied stellar evolution theories as they then stood. When the mission ended, it was considered the most successful astronomical satellite ever. X-ray and gamma-ray radiation originate from the most violent and high-energy cosmic events such as supernova explosions, star collisions, black hole environments, and even the Big Bang itself. This type of light is known as ionizing radiation. Its photons are so energetic that they can separate atoms and molecules into ions and free electrons. XMM Newton, also known as the X-ray Multi-Mirror Mission, is an X-ray space observatory launched in December 1999. This spacecraft investigates interstellar X-ray sources, performing the first simultaneous imaging of objects in both X-rays and optical wavelengths. The XMM Newton is helping scientists to solve a number of cosmic mysteries, ranging from enigmatic black holes to the origins of the universe itself. ESA plans to succeed XMM Newton with the Advanced Telescope for High-Energy Astrophysics, Athena, an X-ray telescope designed to map hot gas structures as well as supermassive black holes. Another important observatory is the Integral, which is a space telescope for observing gamma rays. Integral is an ESA mission in cooperation with the Russian Space Agency and NASA. It was launched into Earth orbit in 2002. Integral is the first space observatory that can simultaneously observe objects in gamma rays, X-rays, and visible light. Its principal targets are violent explosions known as gamma-ray bursts, powerful supernova explosions, and regions in the universe thought to contain black holes. Fortunately, some of the celestial bodies are close enough to visit them. ESA designs and builds special spacecraft that can reach and study in situ almost all objects within our solar system. Our planet revolves around a rather ordinary star, the Sun. The Sun is a middle-aged star, which however produces copious amounts of energy in a more or less stable manner. The Sun's energy drives the climate and sustains life on the Earth's surface. Occasionally, violent solar explosions, called solar flares, and coronal mass ejections occur in its outer layers, which can affect dramatically Earth's environment. Since this is the closest star to us, we can study it in detail in order to reveal all its secrets. This knowledge helps us to predict its violent behavior, as well as to understand the structure and evolution of stars in general. ESA's missions for solar observation began with the Ulysses, which flew in a heliocentric orbit over the solar poles and recorded valuable measurements of the solar wind. More recently, the greatly successful ESA-NASA SOHO mission has been observing the Sun since 1995, providing real-time data for forecasting space weather or how solar activity affects the near-Earth environment. The most recent solar mission of ESA is Solar Orbiter, launched in 2020. This probe observes the solar poles in extreme detail since its highly elliptical orbit can carry the probe within the orbit of Mercury. Mercury is a rather small, rocky planet on the closest orbit to the Sun. The BepiColombo mission, run by ESA and JAXA, comprises 2 satellites launched together on October 20th, 2018, and is currently flying towards Mercury with the arrival planned for December 2025. The 2 satellites are the Mercury Planetary Orbiter and the Mercury Magnetospheric Orbiter. The mission will perform a comprehensive study of Mercury, including characterization of its magnetic field, magnetosphere, as well as its interior and surface structure. Venus is the closest planet to Earth. Its diameter is similar to Earth's and has no satellites. The Venusian atmosphere is very dense and active, composed mainly of greenhouse gases such as carbon dioxide, which cause the extremely high surface temperature of the planet. ESA explored the poisonous atmosphere of this planet with the mission Venus Express, launched in 2005. The main objective of the mission was the long-term observation of the Venusian atmosphere. The observation over such long periods of time had never been done in previous missions to Venus, and was key to a better understanding of its atmospheric dynamics. Mars is the next planet beyond Earth's orbit. Its proximity to our planet made it the next target for detailed exploration. With an armada of spacecraft, we have studied the red planet for several decades. ESA contributed with the mission Mars Express, launched in 2003, which studied Mars and its satellites by providing high-resolution images for more than 16 years and measuring the interaction between the Mars environment and the rest of the solar system. The ESA ExoMars program is currently on a 2-mission effort to explore the red planet further, together with Roscosmos. The first mission, Trace Gas Orbiter, is already orbiting Mars, examining its atmosphere, while the second mission, comprising a surface science platform and a rover, is foreseen for launch in 2022. The mission includes a Russian launch vehicle, an ESA carrier module, and a Russian lander named Kazachok that will deploy the rover to Mars's surface. Once safely landed, the solar-powered rover will begin a 7-month mission to search for the existence of past life on Mars. The giant gaseous planet Jupiter is a very active world, and with an intense magnetic field, turbulent atmosphere full of exotic features, and many interesting moons. In 2022, ESA will launch the mission JUICE, which will study in detail 3 of the most interesting satellites in the Jovian system: Europa, Ganymede, and Callisto, all of which are thought to contain significant amounts of liquid water beneath their surfaces, making them potentially habitable environments. The mission will search for these oceans and will try to detect subsurface water reservoirs. It will also do a topographical, geological, and compositional mapping of the surface of these satellites. JUICE will also study the physical properties of the icy crusts, the internal mass distribution, the dynamics and evolution of their interior. For Europa, the focus is on the chemistry essential to life, including organic molecules, and on understanding the formation of surface features. Furthermore, JUICE will provide the first subsurface sounding of this moon and will determine the thickness of its icy crust. The next planet is Saturn, the most impressive object in our solar system, surrounded by a conspicuous set of rings. Saturn is similar to Jupiter, but smaller. It has the most complex satellite system amongst the planets in our solar system, which exhibits a great diversity in dimensions, structure, and morphology. ESA joined forces with NASA to create a really revolutionary mission to the ringed planet. The mission Cassini-Huygens was launched in October 1997 and visited Jupiter on its way to Saturn, which was its main target. It made the closest approach to Jupiter in December 2000, collecting over 26,000 images of the planet and studying its atmospheric circulation. Cassini-Huygens continued on to Saturn, where it arrived in 2004 and spent 13 years undertaking an extensive exploration of the Saturnian system and the rings and satellites, before the mission ended by plunging into Saturn's atmosphere on September 15, 2017. In January 2005, Cassini deployed the Huygens probe to land on the largest of Saturn's moons, Titan. Huygens then studied the composition of the surface and upper atmosphere. It has revealed Titan to have rain, rivers, lakes and seas of mainly organic composition and a thick, nitrogen-rich atmosphere that might be similar to what ancient Earth was like long ago. Comets are remnants from the formation of the solar system. Most of these ghostly travelers originate from its outskirts, a place known as Oort's Cloud. Every once in a while, some of them get pulled by the gravitation of the large planets into the inner solar system, where they develop their marvelous tails. Giotto was ESA's first space mission to a comet. The spacecraft flew by and studied Halley's Comet, and in doing so became the first spacecraft to make close-up observations of a comet. On the 13th of March 1986, the spacecraft succeeded in approaching Halley's nucleus at a distance of 596 kilometers. Images showed Halley's nucleus to be a small, dark, peanut-shaped body. Analysis showed that the comet formed 4.5 billion years ago. It had remained practically unaltered since its formation. Rosetta was a space probe launched on the 2nd of March 2004. Along with Philae, its lander module, Rosetta performed a detailed study of comet 67P Churyumov-Gerasimenko. On its way to the comet, Rosetta passed through the main asteroid belt and made the first European close encounter with several of these primitive objects. On the 6th of August 2014, after a 10-year journey, the spacecraft reached the comet. On November 12, its lander module Philae performed the first successful landing on a comet. Rosetta was the first spacecraft to orbit a comet nucleus and was the first spacecraft to fly alongside a comet as it headed towards the inner solar system. In the past few decades, astronomers have discovered thousands of planets orbiting other stars in our galaxy. These are strange alien worlds called exoplanets, which exhibit an enormous variety of planetary environments. The ultimate goal of this search is to discover planets that can develop and sustain life, answering at last the fundamental question, are we alone in the universe? ESA is a pioneer in this difficult search. Its older mission, Corot, searched and discovered numerous rocky exoplanets and also made extensive astroseismology studies. Launched in 2019, the most recent mission, Cheops, already studied in detail confirmed exoplanets. The future planned missions, Plato and Ariel, which will be launched at the end of this decade, will be capable of observing in detail the atmosphere of several exoplanets. For thousands of years, European scientists have been asking questions about the universe surrounding us and eagerly looking for answers. Now we know that the cosmos is far vaster and more complex than we have ever imagined, and its exploration demands huge efforts and sacrifices by all of us. Europe is the cradle of modern science. ESA is leading the way by continuing the scientific inquiry and exploration of the universe. caught in our everyday lives, let us remember that we live on a small spinning planet orbiting around an ordinary star amongst the billions of other stars in the Milky Way, which in turn is a typical spiral galaxy amongst many other hundreds of billion galaxies in the observable universe. And our young species, seemingly weak, powerless and dispensable in this huge, violent universe, has one unique strength. The ability to ask questions and look for the answers. The ability to learn and marvel at the magic of the cosmos.